Okay, we're going to start off by finding a reference angle. So we've got the definition here. A reference angle is acute, so that means it's less than 90. It's positive, so it doesn't matter whether you rotate a negative direction or a positive direction. An acute angle is always defined as a positive value. The vertex is at the origin, and the two rays that make up the angle, the terminal side, you have the terminal side of theta and you have the x-axis. So you have your terminal side and the x-axis. Those are always the two rays that make up the reference angle. So let's just go ahead and graph one so you can see what I mean. So if I were to rotate 300 degrees, that would put me about right here. Okay, this is the terminal side. This is 300 degrees. This is the initial side. So the reference angle, oops, the reference angle will always have its vertex. So here's the initial side, vertex right here at the origin, and then here's the terminal side. So this is the reference angle. It's acute, that one's less than 90. And what degree measure is that? That's 60 degrees. All the way around a circle is 360. I went 300. That means the remainder would have to be 60. I guess I didn't draw that to scale, but anyway, get the idea. That would be 60 degrees. So remember, reference angles are positive, so the reference angle for this one is 60 degrees. So this time theta, I'm going to rotate a negative 135 degrees. So 135 degrees is going to go like this. Okay, so that's my terminal side. So we want our reference angle always has the terminal side and the x-axis. So it didn't say the positive side of the x-axis, it just says the x-axis. So I'm going to need this piece right here. Even though that's not my initial side, that's what makes up my reference angle. So my reference angle is this angle right here. So if this is a negative 135 degrees, then this piece right here is 45 degrees, and it doesn't matter that I rotated a negative angle direction, the reference angle is always positive. So that's 45 degrees. Okay, and then 63 degrees, if I rotate 63 degrees, let's say that's like that, that's 63 degrees. All right, so we need the x-axis as our one side, and we need the terminal side as the other. So this is my reference angle, which happens to be the same measure as the angle I have rotated. So the reference angle is 63 degrees. Okay, this one says we're going to draw a reference triangle now. So the reference triangle, the terminal side is the hypotenuse, and one leg is the x-axis, and theta, once again, is at the origin. So I'm going to draw the reference triangle, and I'm going to find the reference angle. I'm going to do both. Now this time we're in terms of pi radians instead of degrees, so that I can figure out where I'm going to graph. I am going to do my scale on this first one. I'm going to do it in ninths. So this right here would be 0. We would start with 0, and then this side over here would be pi. But since I am working 5 pi over 9, I want my pieces to be in 9, so I'm going to make that 9 pi over 9. Then I'm going to take half of 9, so that's 4.5. So this is 4.5 pi over 9. And then I'm going to add 4.5 to my 9, so that's going to be 13.5 pi over 9. That's this radian measure for the moving into the fourth quadrant. And then over here would be 2 pi, but instead of writing 2 pi, I'm going to write that as 18 pi over 9. So now I can tell 5 pi over 9 is just barely into the second quadrant. It's just right there. So that's the angle I've turned. So that's 5 pi over 9. Now I want to make a reference triangle out of that. So I need to have the reference angle in my reference triangle. So remember, even though I rotated, whoops, that not like that, 5 pi over 9. All right, so here is my terminal side. Here is the x-axis. So this is my reference angle right here. And all the way to semicircle would be 9 pi over 9, and I've gone 5 pi over 9, so I know if I subtract them, that this piece right here is 4 pi over 9. My reference angle is 4 pi over 9. Okay, to draw the reference triangle, you need the reference angle. And then you need to just drop your leg down to the x-axis. It always goes down to the x-axis. So you should have a side perpendicular to the x-axis. Always the x-axis. Okay, so let's do this next one over here. So once again, I need to figure out a scale because I'm not really sure. 15 pi over 11. I'm in 11ths. So when I go to set up my scale, this one's going to be 11 pi over 11. If I take half of that, that's going to be 5.5 pi over 11. Add to that, and that's going to be 16.5 pi over 11. And then this side will be 22 pi over 11. That will give me 2 pi. Okay, so now I kind of know what's going on. A negative 15 pi over 11. Now, if I wanted to kind of see where I'd be at, a positive 15 pi over 11, a positive 15 pi over 11 would go about right here like this. So if I'm going to do a negative, then I'm going to rotate the other direction, the same spacing. So I'm going to start here, and I'm going to end here. Okay, that's going to be a negative 15 pi over 11. All right, so we want to find our reference angle. So remember, your reference angle, vertex is at the origin, you need an x-axis and the terminal side. So this is my reference angle inside here. So this was 15 pi over 11 to my terminal side, and a half a circle would have been 11 pi over 11. So that would be a difference of 4 pi over 11. So my reference angle is 4 pi over 11. I want to draw in the reference triangle, so I need my reference angle. Your reference angle makes up two sides of your triangle. And then to get your third side, you always just drop it straight down perpendicular to the x-axis. So there's your reference triangle, and there's the right angle. Okay, and last one, 14 pi over 9. So once again, I'm in ninths, so I'm going to set my scale up, 9 pi over 9, 4.5 pi over 9, 13.5 pi over 9, and this would be 18 pi over 9 for 2 pi. So 14 pi over 9 looks like that would be just a little bit past this y-axis right here. So right here. So there's my terminal side. Okay, so we need to find the reference angle. So remember, the reference angle always has a vertex at the origin. You always have the x-axis and the terminal side. So this is the reference angle because this is the one that's acute. And I rotated 14 pi over 9, 18 pi over 9 would have been a full rotation. So this piece right here is 4 pi over 9. That's my reference angle. So reference angle is 4 pi over 9. Okay, and then we're supposed to draw in the reference triangle. So remember, your reference triangle always has to have your reference angle at the origin. And then you're just going to go perpendicular to the x-axis. And there's your right angle, so that's your reference triangle. Okay, this one says find the exact values of the 6 trigonometric functions of theta. So we've rotated theta. I don't know what theta is, but I can see that I ended up in the third quadrant. So what I'm going to need to do, if I want to find the 6 trig functions, I need a right triangle. So I'm going to need to draw in a reference triangle. So reference angle that would go with that, here's the terminal side, here's the x-axis. Draw that perpendicular to the x-axis, and this is your reference triangle. So this went left 12 units, and it went down 5. So if we do the Pythagorean theorem, we would find out that our hypotenuse is 13. So when it asks you to do the 6 trig functions, remember your angle is always at the origin. So you're going to stand right here at the origin when you do the 6 trig functions. You're always at the origin. It makes a difference because you'll end up with different ratios if you stand at the other angle. So if I'm standing there and I'm going to do my 6 trig functions, sine theta is going to be opposite over hypotenuse. Cosine theta is going to be adjacent over hypotenuse. And oops, tangent theta is going to be opposite over hypotenuse, and you would want to divide that to make that a positive 5 over 12. Okay, the reciprocal functions, cosecant theta is going to be a negative 13 over 5. Secant theta is going to be a negative 13 over 12. And cotangent theta is going to be 12 over 5. So there's our 6 trig functions. Okay, so we'll do this again. So I can see that I've rotated an angle theta. I want to find my reference angle and my reference triangle. So here's my reference angle right here. My reference triangle, I'm going to draw that perpendicular to the x-axis. My reference angle always at the origin, so I'm going to be standing right there at the origin. Let's figure out the side lengths. So it looks like this length is 1 and this is down negative 1. And it doesn't matter, guys, I didn't point it out over on the other problem. It doesn't matter where you draw your triangle, your hypotenuse is always positive. So even if you have some negative movement because you've moved into a quadrant where one of the sides are negative, as far as movement goes, your hypotenuse length is always going to be a positive number. Okay, so if I do the Pythagorean theorem on this, it turns out that this hypotenuse is the square root of 2. And now we'll do our 6 trig functions. So sine theta equals opposite over hypotenuse. We'll rationalize that, and you'll get negative square root of 2 over 2. Cosine theta equals adjacent over hypotenuse. Rationalize that, and it's positive square root of 2 over 2. And tangent theta is opposite over adjacent, and so that's negative 1. So the reciprocal functions, cosecant theta is going to, now I'm going to go back one and I'm going to flip the 1 over the square root of 2. So that's going to be a negative square root of 2. And the reciprocal of cosine theta is secant theta. So once again, I'm going to go back one, and that's just going to be a positive square root of 2. And then cotangent, the reciprocal of negative 1 is still just negative 1. Okay, so there's our 6 trig functions, drawing in our reference triangle and our reference angle. So this one says the point is on the terminal side of an angle in standard position. Determine the exact value of the 6 trig functions of the given angle. So you need to make a sketch on this, guys, and you need to show your sketch in a coordinate plane. So you can't just draw a triangle. You have to draw it in the coordinate plane because we're making a sketch of a point. So make yourself just a quick some kind of a grid mark so that you can see what's going on. That's my X and Y axis. I know I'm moving left 4 and up 10 to create this point right here. Okay. So go back to the origin, and there you go. This is your angle that you rotated to get to that point. You started here on the positive x-axis, and you rotate it to that point right there, and that's the terminal side. So that point's the point negative 410. All right, because we want to find the exact values of the 6 trig functions, we're going to have to use the reference angle. So this is the reference angle that goes with that triangle. So we need to do the Pythagorean theorem and figure out what our hypotenuse is. All right, so if I do the Pythagorean theorem, I get the hypotenuse as the square root of 116, but square root of 116 reduces to 2 square root of 29. Now I noticed that all of these numbers, before I go write my 6 trig functions, I can tell in the triangle. I got a lot of things written here. Let me draw the triangle again so you can see what's going on. All of these lengths in the triangle are all divisible by 2. So if you reduce that before you write your 6 trig functions, then you don't have to reduce later. At some point in time, you're always going to have to reduce the fractions. So it's quicker to do it at the beginning. So these all divide by 2. So this would be 5 and negative 2, and then just the square root of 29. So now when I do my 6 trig functions, when I do sine theta, it's going to be opposite over hypotenuse. And then I'm going to rationalize that, and that's 5 square root of 29 over 29. Cosine theta is the adjacent side, so negative 2 over the hypotenuse. Rationalize that. And tangent theta is going to be opposite over adjacent. And since the 2 is negative, I'm just going to make that a negative 5 over 2. And now our reciprocal functions, cosecant theta, I'm going to flip the second one back, so that's going to be the square root of 29 over 5. Did I say secant? That was cosecant. Secant theta equals negative square root of 29 over 5. And then cotangent theta is going to equal negative 2 over 5. So there's our 6 trig functions. Let's graph that point. Okay, so we're going to do that again. So this time we're at negative 3, negative 5. So once again, you're going to draw yourself a little coordinate plane. Just make a sketch so we can see what's happening. I moved left 3 and down 5. So here's my ordered pair right here. That's the point negative 3, negative 5. Well, this length is, I guess it's not really length, but the direction we moved was negative 3, and the direction we moved down was negative 5. And here's our hypotenuse. So this isn't a 3, 4, 5, guys, because remember the 5 has to be on the hypotenuse. So we're going to do the Pythagorean theorem again. And we get the square root of 34 for our hypotenuse. Okay, so remember, reference angle is always at the origin. So this is the angle you have to use right here. That's where your theta is. Right there. Okay, so we'll go ahead and do our 6 trig functions. So sine theta is negative 5 over the square root of 34. We're going to rationalize that, and we get negative 5 root 34 over 34. Cosine theta is the adjacent side, so that's a negative 3 over the hypotenuse. Rationalize that, and it's negative 3 square root of 34 over 34. Tangent theta is opposite over adjacent, and so that's going to be a positive 5/3. And now we'll do the reciprocal functions. So reciprocal of secant is cosecant theta. And that's going to be a negative square root of 34 over 5. Reciprocal of cosine theta is secant theta. And that's going to be negative square root of 34 over 3. And then the reciprocal of tangent theta is cotangent theta. So that'll be a positive 3 over 5. So remember, you're going to graph that point in a complex plane. I don't have any graph paper, so I just made a sketch. And then you're going to create the right triangle that goes with it, and you're going to use your reference angle to find all of the trig functions that would match that angle rotation. Okay, this one says find the exact values of the remaining trigonometric functions of theta satisfying the given conditions. So we know that cotangent theta equals -3, and we also know that the cosine has to be greater than 0. So I know I'm looking for where the cosine is a positive number. So remember, in your unit circle, cosine is positive. This is what it looks like. We got plus plus, negative positive, negative, negative, and positive, negative. And remember, it's like cosine theta, sine theta. So that tells you the signs in each quadrant. So cosine is positive in the first and the fourth quadrant. So I know it has to be in the first and the fourth quadrant. It's one of those two. But I also know that cotangent is a negative number. So the only place where cotangent is negative is in the second and the fourth quadrant. And how do I know that? Because if you take a negative number and divide it by a positive number, that's going to turn out to be negative. And this one, if I take a negative number and divide it by a positive number, it's going to turn out to be negative. That's the only place where when I do the ratio, I'm going to get a negative number. On the first quadrant right here, a positive divided by a positive is positive. And down here in the third quadrant, a negative divided by a negative is positive. So that leaves me with the second and the fourth quadrant is the only place where cotangent would be a negative number. So that's in the second and the fourth quadrant. So I can see that I'm going to have to put my angle in the fourth quadrant because that's where they overlap. That's where the two conditions are true. That's the only place where both conditions are true. So I'm going to go and put a reference triangle in the fourth quadrant. I'm just making a sketch, so I don't know that I've drawn that to scale. Here's my theta. Remember, it's always at the origin. Cotangent is -3, so in word definition, it's adjacent over opposite. So if I'm going to put my adjacent side in, this is going to be, let's see, we're going to go 3 and then 1. So I obviously didn't draw this to scale, sorry. But my number says -3, but notice if I'm doing the adjacent side, that's not -3 and then 1. The negative sign has this kind of tricky. The negative sign is going down with a -1. And the 3 is the positive. Well, why is that? Because we only write the simplified answer. If you took cotangent theta equals 3 divided by -1, you would write that as cotangent theta equals -3. So just because it says -3 doesn't mean you move left in that direction. You've got to get your triangle in the right spot, and then you can figure out what number is positive and what number is negative. Okay? So I've got everything in there. I'm going to do the Pythagorean theorem to find my hypotenuse. So 3 squared plus 1 squared is the square root of 10. All right, so it says find the exact values of the remaining trig functions. So I know cotangent. So let's see. So sine theta is going to be the opposite side over the hypotenuse. So that's going to be a negative square root of 10 over 10. Cosine theta was going to be the adjacent side, which is 3 over the square root of 10. So that rationalizes to 3 root 10 over 10. And then we already had, oh, we didn't have tangent, but we had cotangent. So tangent theta is going to be the reciprocal of that. So that's going to be a -1/3. We already had cotangent theta as -3. So we just need to do the reciprocals of the other two. So cosecant theta, its reciprocal is going to be minus the square root of 10. And secant theta, its reciprocal is going to be positive square root of 10. So there we go. We found all of the 6 trig functions associated with that triangle. Okay, and that triangle is in the right quadrant. It satisfies both the conditions that were given. Okay, so now this is all about getting your triangle in the right quadrant, guys, and then just using your reference angle at the origin and then just finding your trig functions from there. So this one says the terminal site of theta lies on the given line in the specified quadrant. Find the exact values of the 6 trigonometric functions by finding a point on the line. Okay, so I guess I'm going to graph this line first. There's 4x plus 3y. I don't think you need to have the plus 0. That's your y-intercept. Divide everything by 3. Doesn't change your y-intercept. So here's your slope, -4/3. So I'm going to start here at 0. I'm going to go down 4, 1, 2, 3, 4, over 3, down 4, over 3. I'm going to go up 4, 1, 2, 3, 4, left 3. Okay, so here's my line. Whoops, that's not very straight. Oh, because that point was off. That was never going to be straight. There we go. That looks better. Okay, so here we go. There was my line. But it says they want the triangle in quadrant number 4, and I could pick any point on this triangle. So the nice thing about it is the reason you can pick, now I would pick a grid point, guys. It will make the math much easier. So I would pick this one right here, or I would pick this one down here. And you know what? It doesn't matter. You'll get the same answer. If you pick the smaller one, then you would be going over 3, down 4, and then this would be 5, right? Well, watch what happens if you pick the bigger one. If I pick this bigger one here and I go to here, well, now this side is 6, this side is 8, and that would make the hypotenuse 10. Well, what do they all reduce down to? They're all divisible by 2. It's just a multiple of the 3, 4, 5. Remember, in right triangle trig, they all reduce down to the same ratio. So you might as well use the smallest number. So I think I'm just going to use the blue triangle. Those are the smaller numbers. They're reduced. I could pick any point I wanted, but let's pick the one where the numbers are already reduced. So here's our theta. All right, so sine theta equals -4 over 5. Cosine theta is 3 over 5. Tangent theta is -4 over 3. So then that means cosecant theta is -5 over 4. Secant theta is 5 over 3. And cotangent theta is -3 over 4. So there we go. We've got all of our 6 trig functions. We only needed the part of the line that was in the 4th quadrant. So that's where I drew my triangle. And it said I could pick any point on the line. I picked the smallest grid point possible because then I knew my numbers would be reduced and I wouldn't have to reduce the fractions later. All right, so let's try, this is our last one. So this one says, use the function value to find the indicated trigonometric value in a specified quadrant. Okay, so instead of doing all 6, this is a shorter one. We only need to find the cotangent. We're supposed to be in quadrant 4. So I'm going to go ahead and make a sketch here. In words, I think I need to know what cosecant is. Cosecant's the reciprocal of the sine. So this must be the hypotenuse over the opposite. Now, remember, guys, your hypotenuse is always a positive number. So that says -2. So that is not going to work for your hypotenuse length. So let's sketch the triangle in here in the fourth quadrant. I don't know if I'm drawing this to scale. I'm just sketching myself a triangle. Here's my theta. It's always at the origin. So cosecant is the hypotenuse over the opposite side. So my hypotenuse is going to be 2. That would mean since I have a negative number here, that my opposite side is going to have to be -1. If I were to write that trig function, if I wanted to do the cosecant, I would say cosecant theta equals the hypotenuse over the opposite side, and see how that reduces back to -2. So once again, just because you see a -2 doesn't mean the negative sign is attached to the 2. You're dividing two numbers, so you don't know which number is positive or negative. You're going to have to wait till you draw your triangle to know that. All right, so then I guess we're just missing the other side. So if I do the Pythagorean theorem and I do 2 squared, which is 4 minus 1, that's going to be 3, or square root of 3, sorry. Oh, that looks like our 30, 60, 90s. That's a special triangle right there, pattern. All right, and we're supposed to find the cotangent. So cotangent of theta would be the adjacent side over the opposite side. So that would turn out to be a negative square root of 3. Okay, so in today's lesson, guys, the big idea is to get your reference triangle in the right quadrant and use your reference angle, which is always at the origin. That's where your angle always needs to be, your theta or whatever you want to call it. That's where you're going to stand to do your 6 trig functions or whatever trig function they want you to find.